Hello student, this is the ninth part of functions. In last part I started a special type of functions. First one is one function, defined one function, or injective mapping or injection. A function f maps a to b is said to be one function. Different elements of a are paired with different elements of b. That is, f of x1 equal to f of x2 should implies x1 equal to x2, or f of x1 is not equal to f of x2 should implies x1 not equal to x2. Then only you can say that is a one function. If a function is not one, it is said to be many to one function. Okay. What is the graphical test for one function? This is important. Graphical test. Before that, number of one functions from a to b is n of b, p, n of a. Permutations. How to get this value already explained, are n of b factorial by n of b minus n of a factorial. Okay. So what is this nana here? N of b should be greater than or equal to n of a. So what is the condition? If n of b is less than n of a, no one functions exist. Now I want to explain what is the graphical testing. For example, f of x equal to x square, a function is given. Actually this is not one from, if f is from R to R given, defined by f of x square, then it is not one function. Why? Because take f of 2, that is 4. F of minus 2 also 4. Two different elements are having same image, so it is not one. But how to test graphically? Okay. So you know the graph of f of x y square, x square, f of x square, or y equal to x square, parabola only. Actually this parabola is function but not one function. Just now I explained, but how can you conclude through graph? Do one thing, draw a line parallel to x axis. If that line intersects the graph at most 2 points, if that graph intersects the so draw a straight line parallel to x axis. If that line intersects the graph at more than 2 points, you can say that the function is not gives one function. So for this graph, the straight line is intersecting at 2 different points. From the draw perpendicular on x axis. Say this is x1, say this is x2, 2 different x's. But for example, this output is b, so f of x1 b only, f of x2 also b only. What is the meaning of that? 2 different output or 2 different inputs, same output. That's why this function is not one. So what is the meaning of this nana? F of x1 equal to b only, f of x2 also b only. Different elements having same image. That's why it is not a one. Okay. So graphical test means you need to draw a line parallel to x axis. That line intersect the given graph at more than 2 points. The given graph doesn't give one functional graph. Okay. Okay, next onto function. Or surjection. Or surjective mapping. I will explain. For example, f is a function from a to b. 2, 3, 4, a, b, c, for example, like this. 5 also again, for example. C here. F is a function from a to b. F is not one, no? Because 2 and 3 are different images same. F is not one, but f is called onto here. When the function is said to be onto, that is important. The range of the function equal to codomain. In a function, range equal to codomain. Such function is called onto function. Here, what is the range? Set a comma b comma c. What is the codomain? That also a comma b comma c. For example, one more element is d is there here. Range is ABC only, but codomain is ABCD. In this case, f is not onto. So f is a function from a to b. If f is said to be onto function, range should be equal to codomain. Range means f of a, codomain means b. F of a must should equal to b. Then you can say that is a onto function. Okay, see here a b c d, actually it's not. If d is removed, automatically now this become a onto function. Range equal to codomain. Okay, so if a function is not onto, that is called into function. Function not onto, into. One also into function only. One also many to one function. One is into function only, because not onto, no. Any function not onto called into function. Okay, listen students, f is a function from a to b such that f of a equal to b. Then you can say that f is onto function. F of a equal to b means what the meaning of that? Range equal to codomain. Okay, what is my definition, Anna? Yeah, range equal to codomain. Then you can say that the function is onto function. Another way also you can say that a, the element a is in codomain which have pre-images 2. One is 2 and 3. B have a pre-image, C have a pre-image. For example, D is taken. D doesn't have any pre-image in A, so that's why it is not onto. So another words I can say that every element of codomain should have pre-image in domain. Then the function is called onto function. Okay. So I want to read the definition here. Onto function: if the function f map a to b is such that each element of B, that is codomain, must have at least one pre-image in A, then we say that f is a function of A onto B. Thus f map R to B subject to if and only if every B belongs to B, there exists small a belongs to A such that f of A equal to B. Means every element of codomain should have a pre-image. Understood? That's why, for example, here x is there, here y must should have image of x. That is the meaning of that. All the elements of A should use it up, and every element of codomain also should be used up. Okay, that's why what happened, f of x equal to y. For every y, such x should exist. Then that function is called onto function. If a function is not onto, it is called into function. Okay, so more general you can say that it is range equal to codomain. I will write onto function subject to. Okay, a function f maps a to b is said to be onto if and only if f of a equal to b, that is range equal to codomain. Range of f equal to its codomain. Okay, yeah, first diagram 1 2 3 a b c d also given. Okay, 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 a b 1 2 3 a b. A B F A B F 1 2 3 A B C. Sorry, what happened, Anna? This is not onto, because range is not equal to codomain. This is onto, range equal to codomain, not 1 1 also. This is not 1 1, not onto. This is onto, but not 1 1. So what happened here? This is 1 1 as a result onto. I can say onto. This present type is onto only. I can say onto as well as 1 1 also. Okay. So in this way you can test. Nana, if rule is given, how to find that is important. Rule is given. F maps R to R defined by f of x equal to x square minus 1. Then prove that f is not onto. How to prove theoretically, that is important. First of all, rough explanation, this is R, this is also R. F is function from R to R. Is not onto means you want to show that there exists at least one element in codomain which doesn't have any preimage in domain. Okay. Do one thing. Yeah. X1 y plus 1 root y is minus 10. For example, minus 10 is taken here. Try to find its pre-image. The meaning of that, x square minus 1 should be equal to minus 10, such a way that you want to find x value. Or x square equal minus 9, x equal root over minus 9, which is not a real number. But the meaning of that, there is no pre-image for minus 10. There is no image for minus 11 also. Like so many elements will exist in codomain which doesn't have any pre-image in domain. What is the meaning of that? Range is not equal to codomain. Means given function is not onto. Okay, but how to write theoretical steps? I will show you. Observe, student. Theoretical steps means here. Take any element in which is in codomain, say y. We want to put every y there is x. Every y there is x such that f of x equal to y. Every y there is x such that f of x equal to y. Then you can say that given function is onto. Okay. Yeah. Every y there is x. I will write. Listen. Solution. Okay. Let x belongs to domain. Then there exists f of x, that is y belongs to codomain. Y means f is function such that y is equal to f of x. Reverse process. Reverse process. Checking for function for every x, y is there or not. Reverse process. For every y there should be x. Then only it becomes onto function. Okay. Y equal, instead of f of x, what I can write? X square minus 1. Try to make x as subject here. X square equal to y plus 1. X equal root over y plus 1. Now cross checking. For every y there should be x. For every y there should be x. What is that? What is x and what is it? Both are real numbers, part of real numbers. X is also real number, part of real number, y also part of real number. For every y real, x should be real. Okay, so observe. Here only you can say that for all y's there is no x. For example, y is taken as minus 10. Minus 10 plus 1 minus 9. Root over minus 9 not a real number. Understood? So what happened? Y plus 1 is negative. For such x, such y values, there is no preimage in domain. Okay. Understood? For if y equal to something, any take minus 12, then x equal to root over minus 11, which is not a real number. That is, if y plus 1 is less than 0, that is y is less than minus 1, then there is no x belongs to R in bracket domain. So f is not onto. Complete. What I proved here? For every y there should be x. No. For every y there is no x. Any value y less than minus 1, for such y's there is no x. Okay. Okay, students, for same problem, okay, here R plus is given for same problem. Then prove that f is onto. No, f is not here. Actually, f is onto only. The problem is given. F R to R plus. R to R plus. I am saying R to R plus. This is R and the R plus. R plus means what? Non-negative real numbers. 0, 1, 1 by 2, all. Okay. Now it become onto function. I will show you. See here. Same here. Observe here. Yeah. Take any y nana, which is r plus. Take any y. 0 you take, for example. Root over 0 plus 1. X is 1. Okay. 0 paired with 1. You take instead of y 1. 1 plus 1 root 2. 1 paired with root 2 or root 2 paired with 1, just like that. Okay, means preimage of 1 is root 2, preimage of 0 is 1. What happened here? What is y here? Y is a non-negative real. That's why take any non-negative real number instead of y. Automatically x is a real number only. Means that what is the meaning of that given function is onto function. I will write for every y belongs to R plus and belongs to codomain, there exists x belongs to R in bracket domain. I will write here such that f of x equal to y. So f is onto. Students, very difficult concepts. These all are checking onto and 1 not at all easy. Okay, 2 examples I took, Nana. One is I proved f is not onto. For using this example, I proved that f is onto. Just range of the function should be equal to codomain, then the function is called onto. The function is onto, then it is called into function. Okay. So observation, note, important note. F maps A to B. What note I can write? For example, observe here. 1, 2, 3. A, B, C, D. N of B should be equal to N of A, or N of B should be less than N of A. Then only onto function exists. For 1 function, what is the condition? 1 function, what is the condition? This should be greater than this. But onto function, this should be lesser than this. See here. A, B, C, D, here 1, 2, 3. We are not getting any onto function no, here. We are not getting any onto function. For example, 1, 2, 3, 4 given, here A, B given. Exist, onto function exist. Onto function existing. No? The meaning of this, second set element should be equal to first set element or lesser. So what is the condition? F is onto, then N of A, sorry. Yeah, students listen. N of A must should greater than or equal to N of B. For onto function, what is the condition? N of A lesser than or equal to N of B. Sorry, 1, for 1, what is the condition? N of A lesser than or N of B. For onto, N of A greater than or equal to N of B. Should take care of that. Okay. Note 2. Students, observe none here. This is 1, 2, 3, 4 given. Here A, B given. Only 2 elements in second set. How many 1 functions exist from A to B? That is interesting. How many onto functions exist from A to B? Onto functions. Okay. First of all, how many functions exist? That is important. Functions. N of B power N of A only, no? Number of functions. 2 power 4, that 16 functions exist. 16. All 16s are not onto functions, but we want to identify how many onto functions. Only 2 are not onto, remaining all are onto. I will show you. This is not onto. Among 16, this is one of the function, not onto. All 1, 2, 3, 4 paired with A, that function is not onto, that is constant. One more, 1, 2, 3, 4 is paired with, all are paired with B. This is another constant. It is not onto. Except this, all are ontos only. What is the meaning of that? From A having 4 elements, B having 2 elements, how many onto functions exist? Means I can say 16 minus 2. 16 minus 2. 14 onto functions exist from A to B. Okay. How to generalize this? That is interesting thing. only my generalization is for only if B having only 2 elements. Students, listen. A having 4 elements, B having 2 elements. We want for number of onto functions. First of all, number of functions n of B power n of A. That is 2 power 4 number of functions minus, from this we need to remove 2 constant functions. How many constant functions exist? How many elements are there in codomain? Those many constant functions exist. Here 2 elements are there, 2 constant functions only exist. 2 power 4 minus 2 gives the number of onto functions from A to B. Now I want to generalize. If n of A equal to m, n of B equal to 2, just 2 elements, then number of onto functions from A to B equal to 2 power m minus 2. Okay, this formula is applicable only when second set having 2 elements. If second set having more than 2 elements, how to find? Very difficult task. 1, 2, 3, 4 given. Here A, B, C given. How many onto functions exist from A to B? In this stage you can't find. After completion of concept of permutation combination, we can. But I want to give a formula to find number of onto function from set A to set B. So just one condition, n of A greater than or equal to n of B. That's all. I will show you. Wait. Okay. Yeah, here formula is given. This, by using this formula you can find none. I will enlarge it. Wait. Yeah. So here note 1, note 2 I explained, note 3, n of A less than n of B, then there is no onto functions. Okay. But in A having R elements, B having n elements greater than or equal to the number of surjective mappings or number of onto function. By using this formula you can. How you got this we will discuss in next chapter. Okay. So just try to remember this formula. Important thing is n of A R, n of A R, n of B N. So what is the condition? Your n value should be greater than or equal to 2. So when the onto function is n of A should be greater than or equal to, under that condition. Your R should be greater than or equal to n. R should be greater than or equal to n. In this case, what the formula means? N power R. How to remember? I will say n power R minus nc1 into n minus 1 power R plus nc2 into n minus 2 power R. Alternate symbols, minus nc3 into n minus 3 power R plus 1. What is nc1? What is nc2? In previous article I explained. npr means I explained. What is that? n factorial by n minus r factorial only. But new thing, that is C, here P, here C. P stand for permutation, C stand for combination. I will just write formula. NCR means n factorial by n minus r factorial into r factorial. Should remember this, that's all. So this is the formula for NCR, n factorial by n minus r factorial into r factorial. How you got this? That is in next chapter, that is permutations and combinations. Okay. NCR, just to people should accept it. NCR means n factorial by n minus r factorial into r factorial. NPR means n factorial by n minus r factorial only. So if 4C2 you want, 4C2 means 4 factorial by 4 minus 2 factorial into 2 factorial. 4 factorial means 24. 1 into 2 into 3 into 4 by 4 minus 2 factorial 2 into another 2 2 12 2 6. Therefore the value of 4C2 equal to 6. Okay. By using this formula you can find number of onto functions. Yeah, students, important thing, NPR, permutations. What the meaning, how we got the result, that we'll discuss in the next chapter. NCR, n factorial by n minus r factorial into r factorial. For mathematical convenience, 0 to factorial is treated as 1. Okay. So by using this formula, you can find the number of onto function from one set to another set. Okay, students. Next type, important, 1 onto function. Are bisective. 1 means injective, onto means surjective. 1 onto is called bisective function. Okay. Yeah, listen. If the function f maps a to b is number 1, 1, number 2, onto, then it is called bisective. Understood? A function is said to be bisective, it should be both 1 and onto. That is final conclusion. If a function is both 1 and onto, then it is said to be bisective function. Then it is said to be 1 onto function. Okay, a special type of function and bisective function. It should be 1 onto. Okay, observe here. 1, 2, 3. A, B, C, D are given. F. What type of function this? 1, just 1. Not onto, into. Range not equal to kodamena. Next one. Yeah, not 1, onto this one, onto, not 1. So what I can say, this is only 1. I can't say it is bisective because it is not onto, no. So this is also onto, not a bisective because it is not 1. So observe here. 1, 2, 3, A, B, C. See here. F is 1. Different elements of A are paired with different elements of B. And range equal to codomain, both. This is now bisect. What happened? 1 and onto. This is only 1. This is only onto. This is 1 and onto. Okay. So if function is 1 and onto, it is called bisective function. No condition no here. Here n of b is greater than or equal to n of a. Here n of a greater than or n of b. Here n of a should be equal to n of b. So f is a bisective from a to b. Then what the cardinal relation means? I can say n of a greater than or n of a equal to n of b. Okay, that is note. F maps a to b is bisective. Then cardinal relation is n of a should equal to n of b. Note 2. Number of bisective function from a to b. Or another words I will write. N of a equal to m. N of b also m. Then number of bisective functions equal to m factorial. Should remember nana. What happened here? 1, 2, 3. Here also 1 a, b, c. So here 3, here 3. How many onto functions exist from a to b? Those many are said to be bisectives only. How many 1 functions exist from a to b? Those all are said to be bisective only. How many 1s exist? What is the formula? NPR, no? What is that? 3p3, no? 3p3 means 3 factorial only. Understood? That's why if a set having m elements, second set are also having same m elements, then bisective function exists. Number of bisective functions are m factorial. Okay. Students, here something I wrote. Listen, just listen. If f is both injective and surjective, then it is called bisective mapping. The bisective function is also named as invertible function. Why this is called invertible, we will discuss later. Invertible function, bisective function also called invertible function. Okay. Yeah, next one is why bisective is called invertible function. This is interesting thing. Why it is called invertible function? So I will explain, students. Listen. Through example I will explain. 1, 2, 3, A, B, C, D. Yeah. One example. A, B, C, 1, 2. Observe, students, this is not bisective function, it is only injective mapping, 1 1 function. This is not injective, this is surjective, onto function. So this is both 1 1 and onto. Okay. So first of all, students, listen. F is a relation, not I am saying function, relation from A to B. Then F inverse is also a new relation, that is from B to A. That the concept already completed in relations. F is a relation from A to B. Then F inverse is a new relation from B to A. One thing. If F is a function from A to B, then F inverse is relation from B to A. It need not become a functional relation. Inverse relation need not become a functional relation. I will explain through example here, students. 1, 2, 3. And A, B given. So, yeah, F, A to B. I will write in ordered pairs. F the function 1 to A, 2 to A, and 3 to B. So, this is a relation from A to B as well as function from A to B. Find F inverse, just F inverse. You know how to find F inverse. A comma 1, A comma 2, B comma 3. So this is relation, a set of order relation. Okay, that relation is from B to A. F inverse is a relation from B to A. Okay, but is functional relation or not, that should check. So here A to 1, A to 2. Two ordered pair having same first component, but the definition of function F inverse is not a function. See, you want to write in a arrow diagram. Here A, B given. Here 1, 2, 3 given. A paired with 1, A paired with 2, and B paired with 3. So this is not a functional relation, just a relation from B to A. Understood? That means if F is a function from A to B, inverse need not be a function from B to A. That is important thing. What conditions happen, that is we will discuss. But what I am saying here, F is a function from A to B, then F inverse is a relation from B to A. The relation may or may not be a functional relation. In this example, what I can say, F is a function from A to B, but F inverse from B to A only relation, not a functional relation. Okay. Students, listen. Take one more example. 1, 2, 3, A, B, C, D. Okay. Yeah, F is function from A to B only. A to B to A, not a function. No? A paired with 1, B paired with 2, C paired with 2. But what about D? D is not paired up. That's why F inverse relation from B to A, not a functional relation here. Here also. But take another example. A, B. 1 2 3 ABC. Observe students, write in ordered pair f equal to 1 comma a, 2 comma c, 3 comma b. Find inverse relation I am saying a comma 1, c comma 2, b comma 3. See clearly f inverse also function only here. A C B 1 2 3. Understood? What happened? Here f is a function from a to b. Its inverse not a functional relation, just a relation. Here f is a function from a to b. Its inverse only relation, not functional relation. F is from a to b. Its inverse also function. Okay. F is a function from a to b. F inverse is a relation from b to a. What situation this inverse relation becomes functional? That is important thing. So first function should be bisect. See here. Only this is what onto. Reverse not functional relation. This is 1 1. Reverse relation is not a functional relation. What type of function here? 1 1 as well as onto. 1 1 as well as onto. So f inverse a new relation, that also functional relation. That's why f is a bisective function. Then only f is a bisective from a to b, then automatically f inverse from b to a also another function. That's why bisective function is said to be invertible function. Invertible means inverse exists. Inverse also function. F is function from a to b, it is bisective. Automatically what is your observation here? F inverse also function from b to a. That's why bisective. If a function is bisective, then only it inverse also become a function. That's why bisective function is said to be invertible function. Invertible function. Okay. Understood? See here. What type of function this one? Onto. So inverse need not be a function from a to b. What type of function? 1 1. Its inverse is need not be a function from a to b. Here inverse is not functional relation. Is a functional only relation, not functional relation. Here inverse also only functional relation. Only relation, not functional relation. Here what happened? F inverse from b to a functional relation. That means if a function is bisective, then only it inverse from b to a also function, or another words you can say that invertible function. That's why bisective function is called invertible function. Okay students, important. Okay, finding inverse of a function. Okay, example 1. One, two, three, A, B, C, paired. So directly you can say that F is bisective, no? F map A to B is bisective. Okay, what happened? F inverse B to A also function, it is also bisective. Is also function and also bisective. Okay, so this is important. No, question is given like this: if F map R to R defined by f of x equal to 2x minus 1, then find f inverse of x. First of all, I want to explain the meaning of this problem. F is a function from R to R under this rule. No. Automatically there exists a new relation from B to A, or this codomain to domain. We want to find what is the rule for that inverse. Of inverse is a function, what is the rule for that new function, inverse function? That is said to be f inverse of x. We want to find inverse rule. F inverse means function. F inverse of x means rule. But the rule followed by f inverse function. So here 2x minus 1 is a rule for f function, we want to find a rule for f inverse function. How to find? First of all, we need to check whether f inverse exists or not. F is bisective or not. How to check if it is bisective or not? It should be 1 1 or onto. First of all, you need to check it is 1 1 or not. After that, we want to check it is onto or not. If it is both 1 1 and 2, then you can find its inverse. Okay. So solution. So difficult problem, Nana. Okay. If f inverse exists, it must means f must. I will write another way. If f is bisective, then only f inverse exists. Okay, that's why you need to check for f is bisective or not. How to check? First of all, you need to check f is 1 1 or not. Okay, checking for 1 1. F is 1 1. We don't know. Checking now. Editing that one. How to check? Already explained. Let x1 comma x2 belongs to domain. Then there exists f of x1 comma f of x2 belongs to codomain. Y means f is a function. Next. Yeah, let f of x1 equal to f of x2. What I am assuming, their images are same. What should it gives? If it gives their pre-images are also same, then I can say that it's 1 1. 2x1 minus 1 should be equal to 2x2 minus 1, because f of x1 means clearly given to x minus 1. Okay, so 2x1 should be equal to 2x2. x1 should be equal to x2. What is the meaning of this? F of x1 equal to f of x2 gives x1 equal to x2 without doubt. Therefore, f is 1 1. Okay. Different elements of A are paired with different elements are not. We check logically. Second one is checking for onto. Checking for onto or for onto. Now I want to check for onto. How can you check onto function? What is the procedure, Nana? Every element of codomain should have preimage in domain. This is x, this is y. For every y, there should be x. Means indirectly we want to show that f of x is called y. For every y, there is a preimage x, so that f of x is called y. Reverse checking, Nana. Okay. So let for x belongs to dom of f, there exists y belongs to codomain. Belongs to codomain, I can write that. Okay, because f is a function, that is f of x equal to y. Now you want to prove that for every y there is x. Here 1x, I assume that y is existing. No, actually we want to prove that for every y there is x. Okay, I will prove now. Next page. So f of x equal to y. F of x 2x minus 1 equal to y. Listen, student, try to make x as subject to check for onto. Okay, x equal to y plus 1 by 2. Now you need to check r to r. No, for every r, for every element in codomain, there should be a element in domain under this condition. For every y, x exists. What is r? What is y here? A real number. For every real, x should be real. We need to check. See here, no problem. No? Take any y plus 1 by 2 real number only. So that is, I can write. So for every y belongs to r, there exists a x belongs to r, such that x equal to y plus 1 by 2. That is f of x equal to y. Therefore, f is onto. Okay, so f is 1 1 and onto. That is f is bisective. Next step. So F inverse exists. That's all. F inverse exists. Now how to find inverse rule? That is inverse rule. Okay, this is rule for A to B, R to R, for R to R. This is the rule. Now you want to find this rule. What rule followed by all the elements from Y to V? Automatically this only the inverse rule. Nana. Here somewhere we got this only inverse rule. I will write steps. Okay. Now third one, finding F inverse of X. Okay. These steps are only for descriptive type. For object type, no need to do like this. Directly you can find F inverse. I will explain later. Yeah. Let for X belongs to DOM, there exists Y belongs to codomain. Both are R's only. So that Y is equal to F of X. X equal what is Nana? F inverse of Y only, no here. Y is the image of X under this function. Then X is called pre-image of Y under F inverse. Okay. Okay, this is first result. Second one, F of X is taken as what? Y. F of X 2X minus 1 equal to Y. Try to make X as subject. X equal Y plus 1 by 2. So instead of this X, what I can write? F inverse of Y I can write. F inverse of Y equal to Y plus 1 by 2. Students listen. Students listen. Y, F inverse of Y equal to Y plus 1 by 2. So what is F inverse of K means K plus 1 by 2. F inverse of L means L plus 1 by 2. Actually here X, here Y. But I want reverse rule I want means here this is X, this should be Y. No? Reverse rule I want. That's why instead of Y I can write anything. Therefore F inverse of X equal to X plus 1 by 2. So completed. Students, important thing, listen. F map R to R function defined by F of X equal to 2X minus 1. We want to find F inverse of, directly you can find directly. If it is bisective, directly you can find. In examination we need to check whether it exists or not. So in this exam directly it is bisective. That's why directly we can say the answer. How can you say, see students, directly equating to Y. So 2X equal to Y plus 1. X is equal to Y plus 1 by 2. So what you will get X value? Y plus 1 by 2. Instead of Y you write X. What you will get? That is the inverse relation. See here. X plus 1 by 2. Previously also X plus 1 by 2. Okay. One more thing I will explain you. F of X, for example, 2X minus 3 by 4 given. Nana. Find F inverse of X. Obviously it is bisective only from R to R. I know that. So directly how to find? I will explain. Observe how to write its direct inverse relation. Do one thing. 2X minus 3 by 4 is assumed as Y. 2X minus 3 equal to 4Y. Or 2X equal to 4Y plus 3. Or X equal to 4Y plus 3 by 2. So what happened? What you got? X equal to 4Y plus 3 by 2. So instead of Y you write X. What you will get? That is the inverse relation. 4X plus 3 by 2 is the inverse relation for this function. Okay.